Hi everyone, so this video is on conjugates, conjugate bases, conjugate acids, labeling them in a reaction, as well as writing neutralization reactions. So there's a lot going on in this video. Let's start simple. We're just going to determine the conjugate base of the following acids. So remember, water can be either an acid or a base, or just be neutral. In this case, if I ask you for a conjugate base, we're assuming that it's an acid. So what do acids do? Well, acids lose H. So if acids are going to lose an H, then to get the conjugate base, all you have to do is just take an H off. So if you take an H off, specifically you take an H plus away. So now instead of H2O, I just have HO. Well, there's another way to write that, OH. And don't forget here that if you took an H plus off, then you got to do OH minus. If you start neutral and you take away a positive charge, you're negative. Let's do this one. So HF, I take away an H to get my conjugate base. F minus. Whoopsies. F minus. There you go. So this is the conjugate base for HF. Moving on to this ugly looking thing. This is actually vinegar. It's called acetic acid. This is weird. So the way organic chemists write this kind of stuff, this is an organic acid, they write it sort of like the Lewis structure. Now, good luck taking an H from here. So really, they just take the H that's on the end. So to make this conjugate base, it's just this, except it's this to the negative charge, -1 charge, because we took an H plus away. So hopefully conjugate bases are pretty straightforward. What confuses people here are conjugate acids. So remember, water can be either an acid or a base. In this case, water will act as a base to form a conjugate acid. Well, that's just hydronium. So if you're becoming more acidic or you're becoming an acid, you're adding an H. And because you're adding H plus, you're going to be a positive charge. So in this case, you are hydronium, which is H3O plus. Okay, let's look at this ugly thing. Most bases you're going to see that are weak are going to be some kind of organic base. Well, how do you make an acid? Well, what do? You add an H. So we're going to take this, but instead of H2, I'm going to make this H3. And of course, if I add H plus, I become positively charged. Let's take a look at this one. So the conjugate acid of OH minus, well, let's add H plus to it. HOH. If I add an H plus to the already OH minus, then I'm neutral, and I'm just water. So this one's just water. Yay, that one's nice. So that's how you do conjugates. For conjugate bases, you take away an H. For conjugate acids, you add an H. And they're always going to be paired up. So let's just take a look at this equation real quick. I have formic acid. If I want to make this a dissociation equation, then what I'm going to do is literally just put it in water. Whoopsies. And I already have my symbol ready because I use it all the time. If I am weak, I need a double arrow to do this. So this double arrow here tells you equilibrium. So what's my conjugate base here? Well, that's my minus charge, and that happened because I took an H plus off. So this is the dissociation reaction here. And if you take a look, this is my conjugate base, this is my acidic proton, and this is my original acid. So when you label this, you're going to label this acid, you're going to label this conjugate base, and this is just a proton. This one doesn't matter. Okay, moving on to the next one, we have HBr and NaOH. Well, okay, let's do it. This one is neutralization. So my HBr here is going to react with my sodium hydroxide. Now this is a regular arrow, not an equilibrium arrow, because you're totally just, you're neutralizing. It doesn't go back the other way. Once you neutralize something, it is neutral. So what's going to happen here? Well, the Br here is going to pair up with the Na here. So I'm going to bold these two things. There you go. Double replacement. So H and OH make water, so that's my first product. And then I get NaBr. That's it. Now to label this stuff, this is an acid. This one's a base. This is water. So water's neither in this case. Water is neither an acid or a base. It's just neutral. So this is water. And this is called a salt. There you go. That's your salt. I'm not doing well today. There's your salt. Sweet. Let's move on. This one's going to be a little more different. So HCl pairs with strontium hydroxide. Look at this 2 here. Keep that in mind. So if I add my HCl, which is my acid, and I add that to my strontium hydroxide, again, 1 arrow because it's neutralization. What's going to go together? Well, let's bold it. So my Cl is going to go with my strontium. Uh-oh, watch out here. So strontium is a +2 charge. So strontium goes with chlorine, but there's 2 chlorines. And actually, just to remind you of this, everything is aqueous except for your precipitate. So don't forget that the salt you're forming is actually aqueous. Remember that from lab. We're going to add that to just our water. So there's our water. We're still neutral. So in this case, HCl's are acid. Strontium hydroxides are base. Strontium chloride is our salt. And obviously H2O is our neutral water. So there you go. That's how you do neutralizations. And real quick, I forgot to balance this thing, but you have to remember that for neutralizations, there are 2 HCl's because there are 2 waters on this side. Don't forget that. Because of the OH2 here, I have to double the water, which in turn doubles the acid. And that's what makes the Cl2 continue to be correct. Let's check out one more. I have C5H5N as a weak base dissociation. So I'm going to take this, and we're going to insert our special symbol of our double arrow. If we're a weak base, I need to be at equilibrium. But my shortcut here, just so that you know where the OH comes from, is we're going to add water to this. There you go. So we're going to add our water. And what happens with a weak base is some of it's going to snag this proton off of water. So you're going to get a conjugate acid. Your conjugate acid is going to look like this. Add an H. And when you add an H, you're a positive charge. We're going to add that to OH minus. Now, if you're ever in doubt on if your equation is correct, it has to do with, well, I'm a plus charge here and a minus charge here, and I'm neutral on this side. Your charge on the left has to equal your total charge on the right. So your total charge on the left is 0. Your total charge on the right is also 0, so you're good to go. Moving down, this is your base. This water here actually acts like an acid. There has to be 1 acid and 1 base on each side. That's basically what this means. Haha. This one is a conjugate acid, and OH minus here is our conjugate base because you took the H off the water to make your conjugate base. So there you go. That's how you do neutralizations. That's also how you do conjugates. I hope you have fun taking the test tomorrow. Anyway, peace out.